All right, guys, we are going to be using our trig ratios. In the past, we've been solving for sides in a right triangle. So today we are going to talk about how to solve for an angle. So let's take a look at your notes packet. If you don't have your notes packet to follow along with, you can really use just any piece of notebook paper. That's fine, but you're going to want to write down at least one or two of these examples. Okay, so go ahead and get this ready. All right, so we're talking about 3.4. We're going to talk about solving for missing angles and then solving for some triangles. So let's take a look at this example. So we're just going to kind of think back to algebra. When we solved for x in an algebraic equation, we really have to, get x by itself. And so the first thing that you would do is add 3 to both sides. Why would we add 3? Because we're trying to use an inverse operation of subtraction, right, which is addition. So then I'd get 2x equals 6. And so now if I go to, since this is 2 times x, where the inverse operation, we would then divide, right, to undo that multiplication, and we'd get x equals 3. Likewise, in this other example, we have x plus 2 divided by 3 equals 4. And really what we want to undo first is this division, because that's really like one term. And so once we undo this division with multiplication, whatever we do to one side, we do to the other. And we end up with x plus 2 equals 12. And then we undo the inverse operation of addition is subtraction. So we subtract from both sides. And I end up with x equals 10. All right, so in order to solve for x in this case, we were using the inverse operations, and those are really operations that undo one another. And I'm going to put that in quotes, right? And so if I think about some examples, well, the first one we had was subtraction, and its inverse operation was addition. We then did we had multiplication that we had to undo with division. And if I had division, I undo it with multiplication, right? Vice versa. They kind of works both ways. One of the ones that we've been using more recently was, if I have a square root, then we would undo that with squaring something. Or if something is squared, we undo the squared with a square root. When we are looking at our trig functions, right? I just want to think back, like, square root is an operation. If I take the square root of 5 in my calculator, right, I get a crazy decimal. It's an irrational number. And so that is, if I wanted to undo that, so like, let's just say I then take that and I square it, right? I end up with 5. So when I undo squaring a square root, I end up with that. They kind of cancel each other out, and I end up with the radicand. When we look at our trig functions, if I have the sign of a number, it's not multiplication, it's sine of an angle. So let's say I do 5 degrees, right? That is a decimal, and in this case, it's a negative decimal. So when I'm looking at this, if I wanted to undo this, I need to use an inverse operation. So I'm not like dividing here. It's not multiplication. I'm trying to do the inverse operation of sine, which the way this is written is we have that little -1 as an exponent. And that means the inverse. And so we would say this as sine inverse, or the inverse of sine, the inverse of cosine, the inverse of tangent. And so all of these, when we are using those, we are going to use the inverse operations, right? So inverse trig operations to find angles. So normally I would take sine of an angle, cosine of an angle, tangent of an angle, and I would use that to find the side. Now, if I have 2 sides and I need to find the angle, we're going to use the inverse operation. So we'll show you with some examples here. It really is kind of the same, very similar to what we've been doing. The first thing, we still have to look for the reference angle or the angle that they're asking us to solve for. So that's going to be our reference angle. So circle it, mark it, identify it somehow. I don't like to say label all the sides. Label two sides. Can you bring it here? Label the two sides as the hypotenuse and adjacent or opposite, whatever it might be. And then once we have those two sides labeled, then we can use SOH CAH TOA. Hold on, okay. To determine which trig function. Okay, and then because in the calculator we'll show you how we're going to use the inverse operation to get the angle. So let's look at this first example. So here's my angle that I'm trying to solve for. I just look, here's this one that's labeled 20. I need to determine, is it an opposite leg, adjacent leg, or hypotenuse? And since this one is not touching the angle theta, it is the opposite leg because it forms that letter L, that right angle. And 52 is across from the right angle. It's not a leg. This is the hypotenuse. Okay, so I have O and H. And so that is going to narrow it down to sine. So this says the sine of an angle equals the opposite, which is 20, over the hypotenuse, which is 52. Notice I could use X right here or a question mark or something, but a lot of times they'll use theta for angles. So when we are looking at this one, in my calculator, if I try to just put 20 divided by 52, I'm going to get some decimal. Our angle, chances are it's not going to be some number less than 1. So what I need to do is undo the sine of the angle so I can get the angle by itself. And to undo that, I take the inverse. Okay, and so then when I'm looking at this, let me go back to my one here. How do I do this in the calculator? Well, first, make sure that you are in the correct mode that you are in. I'm going to double check mine. See, mine is in radian mode. So I want to make sure that I go and scroll over to degrees. And then I can quit second mode. Anything that's in blue, like up above, is going to use this second button. And it's also blue on mine. And I believe on the Chromebook calculators as well. So we said we needed to do the inverse of sine and then 20 over 52. So notice here's where my sine button is, and right above it, it has the sine, the inverse of sine. Then it's blue, so I'm going to use the second button. And sure enough, I get the inverse of sine. And we said 20 divided by 52. And I get 22.61. It keeps carrying on. They said to round to the nearest hundredth. So let's go to 22.62 degrees.
Mom.
Hold on, Walker.
What's your
Okay, so we can set up.
password?
Got it. Hold on. We can set up these other ones. Notice we have an opposite leg, an adjacent leg.
Mom.
Okay, and so what? That's O and A. That would be tangent. So tangent of our angle is opposite. I almost wrote that wrong. I'll sit down, please. And so then when I'm looking at this, I want to find the angle. So to find the angle, I need to make sure I'm using the inverse of tangent. And then I'm going to type that into the calculator. Right. The next one, I have to set this up. Determine, okay, I see I have the hypotenuse, and this looks like a leg that's touching the angle, so it's adjacent. That's A and H. That would be CAH, right? And so that's cosine of my angle theta that we don't know yet. Has to equal whatever 6 divided by 8 is. So it's going to be some decimal. I don't want to guess and check, so I take the inverse. And then when I go ahead and use my calculator in degree mode, remember it's second tangent. So the second button, tangent, and then 24 divided by 10. And that answer is 67.38 degrees for our angle. Make sure we're labeling it with degrees and not like feet, because feet would indicate a length of a side, degrees is an angle inside. And then when we look at this one, we type this in. Again, it's not the cosine, right? If I do cosine of 6 divided by 8, I'm not going to get the right answer. I get something crazy small. Chances are, if you get an answer that is like around 1 or less than 1, it's one of two reasons. You didn't take the inverse, or you're in the wrong mode. Very rarely have I ever seen angles that are that small. They generally are going to be, bigger than 1. So if you're getting some numbers that seem really odd, make sure that you're in the right mode. Make sure that if you're finding an angle, you're using the inverse, right? Look what happens when I take the inverse of 6 divided by 8. Yeah, 41.40, let's see, 409, so 41.41 degrees. Sounds a lot more reasonable than 0.999 degrees. That does not seem like a very reasonable answer, okay? So you want to go ahead and practice some of this, and then you can always check back for additional examples. But make sure you do some of the practice that's accompanying it, that classwork 3.4, so that you can see where you have some questions, and make sure you understand when to use the inverse, when to use a normal trig function, how to use your calculator, how to get it in the right mode. These are all the things that we want to practice before we have our test or our quiz. Okay. And as always, email or see me in the mornings if you have any questions. Can you bring that here for me? That's Daddy. Let me do it. Hi, sorry, I was recording.